Hello students, I am Vidya from G.K.Jain school. Now I am going to teach you about inertia in class 10. Listen, what is inertia? The inherent property of a body to resist any change in its state of motion or in its state of rest. So this is what known as inertia. For example, when we travel in bus, when sudden brake is applied, our upper part of the body will tend to move in forward direction because our body continue to be in the state of motion. But when sudden brake is applied, our upper part of the body alone will lean forward direction. In a similar way, when the bus at rest, okay, our body also in the state of rest. But when bus started to move, our upper part of the body will lean backward direction because our body tend to continue to be in the state of rest. So these are the example for the inertia, and also I will do one activity for the inertia. So that will make you to understand better about the inertia. What is inertia? Now we are going to see about what are the classification of inertia. See, types of inertia has been classified into three. One is inertia of rest, and inertia of motion, and third one is inertia of direction. So first we will see about what is inertia of rest. The body resists to change from its state of rest. If the body resists to change from its state of rest unless it is acted upon by external unbalanced force. Okay, unless it is acted upon by external unbalanced force, it continue to be in the state of rest. Then it is known as inertia of rest. For example, when we shake the branches of tree vigorously, what will happen? The leaves and fruits will detach from the branches and it will fall down. So this is the good example for the inertia of rest. Now we come to inertia of motion. The body resists to change from its state of motion unless it is influenced by some external unbalanced force. Then it is known as inertia of motion. For example, an athlete runs some distance before jump because that enables him, that helps him to jump to cover longer distance. So this is the one good example for the inertia of motion, because when he runs in the motion. Okay, he is in the motion, so it continue, an athlete body continue to be in the motion that enables him to jump longer distance. Okay, and next one is inertia of direction. So inertia of direction means it depends on the direction. That means when we take sharp turning while driving a car, we tend to move in sideways because our body tend to continue to be in the same direction. But suddenly when we take a sharp turning in a car, our body will lean sideways. Okay, so this is the good example for the inertia of direction. I hope you get understand about the inertia and the types of inertia. Now we are going to perform one activity to understand the concept of inertia. Take a glass of water and take one cardboard and keep 1 rupee coin on that. Okay. Now we are going to check the inertia of the 1 rupee coin. Okay. So now the coin at rest. Now we are going to check whether this coin tend to continue to be in the state of rest. Okay. See, when you flick the cardboard, what will happen? The 1 rupee coin fell into the glass of water. So from that, what you can understand, that 1 rupee coin continue to be in the state of rest. So that is why it is not come along with the cardboard, it fell down into the glass of water. So this is the example for the inertia. Now I am going to teach you about linear momentum. The impact of a force is more if the velocity and the mass of the body is more. To quantify the impact of force exactly, a new physical quantity is known as linear momentum. The definition of the linear momentum is: the linear momentum of an object is the product of the object's mass times its velocity, and the linear momentum is denoted by the symbol P. Here I have mentioned the linear momentum symbol and the formula. So the product of a mass and their velocity is known as linear momentum. The linear momentum is a vector quantity because it consists velocity. Since this velocity is a vector quantity, the linear momentum is a vector quantity and has the same direction as the velocity. It has the same direction as the velocity. And the SI unit of linear momentum is kilogram meter per second. So this is what the SI unit of linear momentum. The product of mass and velocity of a moving body gives the magnitude of linear momentum. It acts in the direction of the velocity of the object. Okay. Now let's see one example for the linear momentum and how to calculate the linear momentum. A glass window can be broken by the impact of the force when the mass of the ball, okay, so mass of the ball thrown with a greater velocity. Here we can measure the impact of the force which broken the glass window as a physical quantity. So let's consider the mass of the object. Okay, so the mass of the object means the object we are taking as a ball here. So mass is 150 grams. So now when we convert it into kilogram, it can be taken as 0.150 kilogram. And the velocity of the ball is 25 meter per second. Now we can calculate what is the impact of the force. That means what is the linear momentum of the object. See here. So linear momentum, the symbol is P. That formula is mass into velocity and the SI unit is kilogram meter per second. Okay. Now substitute the mass value here, that is 0.150 kilogram into velocity is 25 meter per second. When we calculate this mass and velocity, you will get the answer. What is the result? 3.85. So the unit is kilogram meter per second. So this is the impact of the force given by the ball.
Subscribe now and press the bell icon. Never miss an update.